Hello and welcome to day 2 of centers of a triangle. If you remember from last time, we talked about the circumcenter of a triangle, and this is when we created the perpendicular bisectors of a triangle. Today we're moving on to the next center. So we're going to do a GeoGebra construction. So once again, you should have GeoGebra open on your computer. I'd like you to turn off the axes just like we did last time. So for this, you right click and select axis, and that'll turn it off. You can also turn your grids off in the same location. Now we're going to make a triangle. This is the 5th icon over. Drop down menu, select polygon, and put 3 points on the screen. Once again, you have to connect it back to point A. Now, for this center, we are going to make the angle bisectors. What an angle bisector is a line that divides the angle in half. So to make this line, you go to the 4th icon over to the drop down, and it's the 4th one down labeled angle bisector. In order to bisect an angle, you have to choose the 3 points that make up the angle. Okay, you can choose these 3 points in any order. I did B, A, C. To do the angle bisector of angle B, we're going to go A, B, C. And once again, this generates a line. And we need to do this also with C. So B, C, and then A. If you notice, these lines all intersect at a point. Alright, so we call these lines concurrent. This point is called the in-center of a triangle. So just like last time, I'd like you to label it. You can get a text box from this icon here and select text. And click anywhere on the screen. We're going to label this the in-center. Alright, just put that by that point. To make this an actual point, we need to go to the top, select the drop-down menu by point, and select intersect. To do this, you highlight one line and then highlight another, and point D will appear where the 3 lines intersect. This point, once again, is called the in-center of a triangle. It is where the angle bisectors intersect. Okay, the interesting thing about the in-center of a triangle is that it is equidistant from this point to any of the 3 sides. To show this, we are going to drop perpendicular lines from D to each of the 3 sides. So you're going to go to the top under the line. This will be under the 4th one over. This will be perpendicular line. And you're going to draw a line from D to the line, from D to the other, and from D to the 3rd. So now I have the 3 perpendicular lines that go from D to each of the sides. Remember that to find the distance between a point and a line, we have to make it a perpendicular line because that would be the shortest distance, and that's what we're interested in. Okay, now we need to go to the top and we need to do another point of intersection. So this is the 2nd one over. Choose intersect, and we need to get the point where the line intersects the side. So you need to go around and see the perpendicular line, and you need to choose where it intersects the side. Okay. So I click on the perpendicular line that I made, and then I click on the side that it intersects. Okay, this gives us points of reference on each end of the line so that now we can look at the length. To find the length, you're going to go to the 8th icon over. Click the drop-down menu and choose distance or length. Okay, now you're going to go from D to E, and it'll put a length. Go from D to F, and it will put a length, and go from D to G. Okay, what this shows is that, in fact, these lengths are all the same. If you would like, you may pick up the Move tool, and you can move your triangle around. And notice that no matter what shape our triangle makes, whether it's kind of normal, kind of funny, no matter what, these 3 lines all stay the same length. Okay, last time we found out that the circumcenter of a triangle is equal length to each of the vertices of the triangle. And so we created a circle that went around the triangle. Today what we're going to do is we're going to create a circle with the 6th icon over, but this time it's going to go through each of the points that we created on the side of the triangle, since these are all equidistant away. So choose the 6th one over, and you need to choose circle with center through point. Okay, you will click on point D, and you will click on one of the 3 points. Okay, notice how even though I clicked on point F, my circle actually goes through E, and it also goes through G. Okay, so this circle is what we call inscribed in the triangle. Inscribed in the triangle. And what that means is that this circle touches all three sides of the triangle, and it stays inside the triangle. So this is an inscribed triangle. Or sorry, an inscribed circle inside of our triangle. So if you take the move, click on the move button again, you can pull your triangle all around, real funny, and that circle always stays inside of it. Alright, thank you for watching my video. You can now put your name on your GeoGebra. I'll put Mrs. Spencer, but once again, you need to put your name. Alright, and you will go File, and you are going to download this. So you go to Export, download it as a PNG, and you will email this to me at my email address, which is rebecca.spencer@ga.ozark.k12.mo.us, and here it is on the screen. Alright, thanks for watching. I hope that you enjoyed making the end center of a triangle, and we have 2 more days left, so we're going to learn about 2 more centers of a triangle.